Good morning, students. Myself, Dr. Eustace Russell, working as Assistant Professor in the Department of Mechatronics Engineering at Sri Muthukumaran Institute of Technology. Already we have discussed this subject, kinematics and dynamics of machinery, in the Unit 1 of Part 1 and Part 2 we completed. Now we are going to see in the next topic of velocity and acceleration diagram in upcoming slides. So this is a syllabus we have already discussed in the first part of this unit. In this we are going to see the velocity and acceleration polygons. Today we are going to discuss the topic. So this topic is very interesting as well as important one. Students might have across this topic, studied this topic in physics, that is a motion of velocity, relative velocity, angular velocity, various type of velocity we have discussed, we have seen in the school days. As we discussed in the earlier part 2 slide, the various inversions we have discussed, that is first inversion, second inversion, third. In the various inversion we found that some mechanisms that will be followed, that is 4-bar mechanism, otherwise one link will be fixed and another one will be under motion. Various part we have seen. In this slide we can see one of the slider crank mechanism is given. In that, whenever the angular velocity is given in the crank OB, what will be happen means the velocity will be acting perpendicular to OB. You can see VB, that is acting perpendicular to OB. That is the input that is given to the crank. How it is rotating? It is rotating in clockwise direction at the velocity turns to move in the upward direction. That is V equal to omega R, that is acting perpendicular to that link. Now we are going to see the velocity diagram in the right hand side of this slide. Why VA is given in a horizontal direction? Because the slider part is moving from one point to another point. That's why it is given. That is only slider motion. With respect to point O, this slider part is moving in a horizontal direction. So that's why it is given as VA. The next part is VB. As I already told, VB is acting perpendicular to OB link. That's why we drawn one line perpendicular to OB. And the closing side of the polygon, that is nothing but AB. AB is the another one link. If you are drawing another one perpendicular line to AB, you will get a closed polygon of this mechanism. Now followed by acceleration analysis of 4-bar mechanism. We can see one link is acting over there, that is AB. Here we are going to discuss about two various components. One is radial component, that is perpendicular to velocity. So whatever we have drawn in the velocity diagram, we have to take the perpendicular line to that velocity diagram. And what is tangential? Taking parallel line to that velocity of the particle. Two formulas which I have highlighted here. That is radial component is mentioned by A super suffix of R to the super suffix of, subscript of capital BA, which is equal to omega square AB, again it is equal to V square BA upon AB. Tangential, that is ATBA, equal to alpha, that is nothing but angular acceleration, it is mentioned over here, that is alpha into AB. Unit is radian per second square. Unit of angular velocity, radian per second. It is mentioned in the slide. Now this is the problem we are going to discuss. This is a very important problem. This type of questions the university might ask in the final examination. And a very simple question also. That is a 4-bar mechanism it is given, that is ABCD, and the AD is fixed. That is the length is given 150 mm long. Crank AB is 40 mm long, rotates at 120 rpm clockwise, while the link CD 80 mm oscillates about D. BC and AD, that is BC and AD are of equal length, it is clearly given. Some calculation it is given, N of BA equal to 120 rpm, omega BA equal to 12.568 you will get. This is a space diagram you have to draw. Based on the space diagram is drawn with the original dimension. We have to change it to our record scale, then only it is useful to draw. Because 150 mm is nothing but 15 centimeter almost it will take. So it is very big size, means we can reduce the scale and we can draw it. And based on the velocity diagram, as we discussed already, taking perpendicular lines. Perpendicular lines, first you have to start with AD is the fixed. From that BB we can get. Then drawing perpendicular line to BC. Then again closing polygon is BCD. So this construction of this velocity diagram is clearly mentioned in this slide. What is a working drawing construction part? It is clearly given. By measuring the measurement from the velocity diagram, we can get omega CD. From that calculation only we can get it, which is equal to V subscript of CD upon CD, which is equal to 0.385 divided by 0.08, and you will get 4.8 radians per second. Then again one problem. This is one slider mechanism. Previous problem we have seen only 4-bar chain mechanism. This is slider crank mechanism. The same problem, but a different dimension it is given. Speed, that is 300 rpm is given. Crank is 150 mm. Connecting rod is 600 mm long. Determine the linear velocity and acceleration of the midpoint of the connecting rod. It is clearly given. That is what we are going to find, that is asked in the question. Linear velocity and the acceleration of the midpoint, as well as angular velocity and angular acceleration of the connecting rod. And the crank of 45 degree from the inner dead center position. It is clearly given. The inner dead center position is 45 degree. That is also given. The initial step we can do, VBO we can find with the help of the angular velocity. What it is given, speed is given, we can easily find the angular velocity, that is 31.42 radian per second. With the help of that we can find the value as 4.713 meter per second. This by using this formula, omega BO into OB. Then the same procedure, the velocity diagram what we had discussed in the previous problem, we have to take the perpendicular line to OB. Starting point is, what is the starting point here? O is the starting point, VB is the initial line we are going to draw. Then taking perpendicular line to AB, and finally you will get one line. Then closing is nothing but VA. What I told VA means it's horizontal line, because whenever the sliding part is there, no need to worry, draw only the horizontal line along x-axis. So this is a velocity diagram. This yellow color, golden color line that is mentioned in the velocity diagram represents the midpoint of the connecting rod. The velocity of the midpoint of the connecting rod, it is mentioned with the hidden lines. You have to take the midpoint of that BA and join with O, because the midpoint that is moving with the response to the origin point O only. So again, this followed by acceleration diagram, having the two important components we are having over here. What are the two important components means? That is AR BO, that is nothing but V square BO by OB, that is 4.713 square, divided by 0.15, that is we will get 148.1 meter per second square, followed by radial component, that is V square AB by BA, and which is equal to 3.4 square divided by 0.6, equal to 19.3 meter per second square. In this acceleration diagram, we can see basic diagram, the radial component we have to mention over here. with the help of these two dimensions, we have to draw the parallel line and the perpendicular line. Closing side, we will get the acceleration of the line. That is AB, AD, and A of A. A of A. So this is the reference, one reference which I took for this preparation of this slide, that is velocity and acceleration diagram. Kindly go through it, go through this reference, and also go through this slide. So thank you all students for your kind attention for this session called velocity and acceleration polygon. So kindly go through these topics, it will be more useful. So all of you go through the video, please subscribe it, share to your friends. Thank you.